Hello everyone, welcome back to my channel. In this module, we are going to study solid states physics. So by the end of this session, you should be able to answer, differentiate between amorphous and crystalline solids, analyze important crystal parameters, and 2D Brevis lattice. So let's begin. Okay, so let's start with solids. Basically, what solids are? Solids are the things that have a definite shape, a definite volume, and cannot be compressed. Do not fill the container. So, solids are the things that have a definite shape, such as a cube. It has a definite shape. It cannot be turned into something else. Or, take an example of a phone. A mobile phone has a definite shape, a definite volume, and it cannot be compressed. I mean, it can be, but if we do compress it, it's no longer be a phone. It would be broken. Okay, so let's move forward. Introduction to solid states physics. Basically, in this module, we are going to learn about what is the latest lattice points, crystal structures, what are crystal planes, what is a single crystal, what is a polycrystal, and so on. Crystalline versus amorphous solids. The property of a crystalline solids are they are arranged in regular and a repeating manner. They have a long range order. Their melting point is sharp. They have a definite geometric, means they're arranged in a sequence manner. Their nature is true solid. Property is anisotropic. Examples are salts, NaCl, quartz, diamonds, and metals. Now, let's just go ahead with amorphous solids. Amorphous solids are irregular and random arrangement. Their order are short range orders. Their melting point is gradual, that is softened, not that sharp as that of a crystalline solid. Their shape, they do not have a definite geometry as of the crystalline solids. They are supercooled liquids. Their property is isotropic. Examples of amorphous solids are glasses, plastics, rubber, wax, that all comes under amorphous solids. This was the clear differentiation between crystalline and amorphous solids. Students, you have already seen the difference between crystalline and amorphous solids. Now, let's go through their definitions. A crystalline solid is formed by regular repetition of building blocks, that is, atoms or molecules, in a three-dimensional periodic array. The example of crystal are table salt, NaCl, diamond, snowflakes, metals, ice, and ceramics. Now, the amorphous solids, that are the materials in which constituents, atoms, or molecules are not arranged in a regular manner over a long range. There is periodicity in nature. It periodicity occurs. It must be over a short distance. Examples of amorphous solids are glass, rubber, plastic, etc. Now, let us go ahead with crystalline solids. There are few terms that are used to define crystalline structure or crystal structure. Lattice. Lattice defined as a regular periodic array of points in space. Each point in a lattice has identical surrounding everywhere. Lattice is basically imaginary points on space with a periodic manner. Means there is a point arranged in a periodic manner, that is an sequential order. Now, what is bases? Atoms or molecules which are constituent of a crystal material. Example, like we have NaCl crystal, NaCl molecule, a group of one Na and one Cl forms bases. Means one Na molecule and the other Cl molecule or atom forms a base, that is NaCl. Okay, so in this slide we are going to see the diagrammatic representation of lattice points in 2D and 3D dimension. In figure 1.2, you can clearly see that the points are arranged in a periodic manner in an imaginary space, in an imaginary way. Similarly, you can see that in figure 1.3, the points are arranged in the 3D manner, forming a cube with the same periodic manner imaginary points. Now, the crystal structure. Basically, the crystal structure is formed by the lattice plus the base. That is, the lattice and the base from the crystal structure. As you can clearly see in the diagram, the lattice points and the base are forming a complete crystal structure. Now, in crystal structure, how to find it? So basically, there are three fundamental vectors in a lattice point crystal that can be denoted. That is n1, n2 and n3 are integer numbers, and a1, a2 and a3 are lattice translational vectors. So the lattice translational vector T is a vector which can connect any two lattice points, and T is given by n a1 plus l a2 plus m a3. This is a diagrammatic representation of the formula that we studied in the previous slide. Have a close look. Let's move forward to a new topic: unit cell and primitive cell. What is a unit cell? It is convenient to divide the crystal into small entities such as group of atoms or molecules. It is a well-defined arrangement. These small cells are called unit cells. The unit cells are building blocks for construction of crystal structures, that is A1, A2, A3 and so on. A unit cell can be completely described by the lattice vector. What is a primitive cell? A primitive cell is the smallest volume cell of a crystal. We often use primitive lattice vector to define the axis of crystal. Translational vector are primitive vectors. If these vectors form three adjacent edges of parallelepiped of smallest volume, then what is the difference between unit cell and primitive cell? That is, the primitive cell always contain lattice point only at corners. What's the difference? The primitive cell have only the lattice points at the corners. It's an important question to remember. Types of crystal lattice. 2D crystal lattice. Consider any two lattice vectors for defining any point. Now, the simplest transitional T that we can write from here is T is equals to N A1 plus M A2. Here is a clear diagrammatic representation of five distinct type of lattice in 2D dimension called the Bravais lattice. As you can see, The two vectors in the one are forming a square. Therefore, this in the second one you can see they're forming a hexagon as they are at different angles. We can form different crystal structures while choosing the two vectors in a 2D crystal lattice. Students, that's it for this module. We'll complete and continue the other parts in a second module. Stay tuned for that. Till then, please go ahead and complete this activity quiz for revision. Drop your doubts in the comments. Thanks for watching.